Hi friends, so today let us learn is matter around us pure using question and answers. Okay, first question, what does scientist mean when he says something is pure? Answer is, for a scientist, pure means substance consists of single type of particle. So it should have either a single molecule type of molecule or a single atom. Okay, so only if it has single type of particle, either an atom or a molecule, the scientist says it is pure. What are some of the examples we might think are pure but are actually mixtures? So pure milk is actually a mixture of water, fat and proteins. Okay, seawater is a mixture of water, salt, minerals, etc. What is a mixture? So a mixture contains more than one pure substance. If you take for example water, which is pure, and salt, which is also pure, but when you mix these both, okay, water, you dissolve salt in water, you get a solution which is a homogeneous mixture. So mixture contains more than one pure substance. What are the two types of mixtures? One is a homogeneous mixture where the composition of substances is in same ratio in the whole mixture, which means that if you, for example, dissolve salt in water, no matter which part you look, the number of molecules of salt, that is sodium chloride, and number of molecules of water will be in the same ratio. No matter where you see, it is homogeneous, it is continuous and combined in a continuous form. Okay, for example, if you do dissolve sugar in water, ratio of sugar molecules to water molecules will be same. Okay, heterogeneous mixture, on the other hand, the mixture is not uniform. The composition substances will be in different amounts in different parts. Okay, if you mix sodium chloride and crushed iron filings, okay, some iron filings may have more salt on them, some iron filings might have less salt on them. So the mixture is not uniform, it is heterogeneous. Somewhere there might be more sodium chloride and less iron, some other place there may be more iron and less sodium chloride, and so on and so forth. Okay, what is a solution? Give example of liquid, gas and solid solution. A solution is a homogeneous mixture of two or more substances. Liquid solution examples are lemonade. So for example, if you put lime juice and sugar in water to make lemonade, this is a homogeneous mixture, right? In all parts of it, the composition will be uniform. If you take soda water where you have mixed carbon dioxide in water, CO2 is carbon dioxide and H2O is water. Carbon dioxide, CO2, has one atom of carbon and two atoms of oxygen. That's why it is CO2, right? And H2O has two atoms of hydrogen and one atom of oxygen. That's why it is H2O. Okay, and you have salt water or sugar water or iodine in alcohol. All these are liquid solutions and they are homogeneous. What about gas solutions? Very good example of a gas solution is nothing but our air. Our air has large amount of nitrogen, okay, and it has a little amount of oxygen. I mean, in the percentage times it is 70-30, but anyway, it has oxygen, it has argon, and it has carbon dioxide, and a small amount of other gases. Okay, so mostly it's made of nitrogen and oxygen. 70% nitrogen and 29% oxygen, and other gases are lesser in percentage. So you have solid solution also, which are called alloys. For example, brass. Brass has 30% zinc and 70% copper. So when you mix these both metals, you'll get another metal called brass, and that is a sort of homogeneous mixture, and it is a solution of a solid in another solid. That's why it's called alloy. What is a solvent? What is a solute? Okay, a solvent is a substance in the solution which is in larger quantity. That is what dissolves the other. For example, if you dissolve salt in water, water is in more quantity, right? So that is the solvent, and salt is what gets dissolved into that water, right? So that is the solute. Solute is a substance in a solution which is smaller in quantity and it gets dissolved, right? The one who dissolves is the solvent, one who gets dissolved is the solute. For example, salt. Okay, what are the properties of solution? Properties of solution are the particles are smaller than 1 nanometer. 1 nanometer is 10 power minus 9 meters. Okay, so 10 power minus 9 minus 9 meter or 1 upon 10 power 9 meters. Okay, so they cannot be seen by the naked eye, and they do not scatter the beam of light passing through them, so that the path of light through the solution is not visible. For example, I'll show you an image in the next in this video after some time. If you take a laser pointer and shine it through a solution, you will not be able to see the path through the solution. Okay, and the solute particles cannot be separated from the mixture by process of filtration. So they are so small enough that you cannot filter them out. Okay, you need other kinds of processes, but you can't filter it out. Yeah, if you dissolve salt or sugar in water, to separate them, you can heat the solution and you can evaporate the water, and the sugar or salt will be left out. You can do that, but you cannot filter it. Okay. So what is a saturated solution? What is an unsaturated solution? Saturated solution is at a given temperature, maximum amount of solute is already dissolved. Okay, so if you take some water and you put some salt into it, it gets dissolved. You put some more salt into it, it gets dissolved. Some more you put into it, it gets dissolved. If you keep on doing this, after some time you'll notice that even if you put more salt, it will not get dissolved. What that means is the maximum amount of salt is already dissolved. There is no more space for any more salt to get dissolved. That is called a saturated solution. An unsaturated solution is where the maximum is still not reached. You can still dissolve much more. Okay. How can the concentration of the solution be expressed? It can be expressed as a percentage of mass of that solute divided by percentage of mass of solution multiplied by 100. For example, let's say you dissolve salt in water. Let's say you dissolve 40 grams of salt in 320 grams of water. Okay. Now the solution together will weigh 40 plus 320, that is 360. Correct? Now the concentration is nothing but the mass of the solute, which is 40, divided by mass of solution, which is 360, multiplied by 100, which is 11.11%. Okay, what is suspension? See, suspension is different from solution. Solution is a homogeneous mixture where you can't even see the particles, but suspension is a heterogeneous mixture. Okay, so the spread is not uniform. The solids are dispersed in liquids. These are called suspensions. Okay, a heterogeneous mixture wherein small particles of solid visible to the naked eye are dispersed in liquid is called suspension. Okay, this is different from solution. For example, if you just take chalk powder and you crush it well and you put it in water and you stir it, what you will get is a suspension. Okay, what are the properties of suspension? See, the particles are not small enough. In case of solution, when you put salt into water and stir it, it gets dissolved, right? So you can't see the particles at all. The particles of salt cannot be seen by naked eye. They have become so small. But these particles in the suspension are big enough to be seen by the naked eye. Okay, so chalk powder, if you crush it and put it in water and stir it, it will not get dissolved. So you can still see the chalk powder particles in the water. Okay, it will scatter a beam of light passing through it, making the path visible. You can see the path of the light beam because the particles in the suspension are scattering the beam. Okay, solute particles settle down when the suspension is left undisturbed. So suspension is unstable. So if you take chalk powder and put it into water and stir it, and if you just leave the beaker on the table and let it be for some time, you will see that all the particles will come down and settle at the bottom. Okay, so if a suspension is sort of left undisturbed for some time, all the suspended particles inside the suspension will settle down. Okay, and they can be separated from the mixture by a process of filtration. So once it separates, you just pour water through the filter paper and you can separate out all the chalk powder from the water just by filtration. You don't need to heat it like in case of a solution. In suspension, the particles can be separated from the solvent by just filtering it. Take a filter paper, pour the suspension through this filter paper, and all the particles will get collected on top of the filter paper. Okay, what is a colloidal solution? See, colloidal solution is something in between solution and a suspension. Okay, that's why it's called colloidal solution. It's in between solution and a suspension. These are heterogeneous systems. They are not uniform, they are not homogeneous, but the particles are still small enough that they are not visible to naked eye. Okay, and they still can scatter light also. For example, milk or drops of ink in water or particles of smoke in air. See, this kind of system is heterogeneous and it is somewhere between the solution and the suspension. Okay, this is the third type. It's called colloidal solution. Okay, what are the properties of colloidal solution? Particles are small enough, they cannot be seen by the naked eye. So in this way, there's particles are not as small as what are there in the solution. They are big enough, but they're not big enough to be seen by naked eye. Whereas in suspension, the particles were big enough. Here, the particles are not big enough. You cannot see them in the by the naked eye. But the particles are large enough to scatter a beam of light. Okay, when you passed a beam of light through the solution, the particles were very small, so you couldn't see the beam of light. When you passed it through a suspension, yes, you could still see them, right? Because particles are very big. Now the particles are somewhere in between, but still they can scatter light, so still you will be able to see the light pass through this colloidal solution. Okay, particles do not settle down when left undisturbed. Remember, when you put a chalk powder in water and you just kept it on table, all the chalk powder settles down at the bottom. In colloidal solution, this does not happen. Particles are small enough and they keep moving around in the solvent, and it's a heterogeneous mixture that stays stable. Okay, they cannot be separated by filtration. Remember, for chalk powder, all you did is you took a filter paper and you poured the water, and all the chalk powder was collected on the filter paper. But here you cannot separate the particles from the colloidal solution by filtration. You have to use centrifugation. Okay, centrifugation is a process where particles in colloidal suspension can be separated. What is Tyndall effect? We thank Wikipedia for this image. It is the scattering of light beam when it passes through a suspension or colloidal solution, making its path visible. This is called as Tyndall effect. Okay, thanks to picture from Wikipedia, you can see that a person having a laser pointer is shining it through a beaker which has a colloidal solution, and you can see that the path is seen. But on the left side, the same beam goes through a beaker having salt water. Right? Salt water is a solution. The particles are not big enough to scatter the the light beam, so you cannot see the path of the light through this solution. Okay, give example of colloidal solutions. Table gives information about the colloids. Not to remember all, just for information. Friends, you don't need to remember this. Okay, you just need to know this. Don't try to remember this by heart, but just for information. See, if I disperse liquid in gas, I get what is known as aerosol. Okay, for example, fog, clouds, mist, all are water dispersed in air. Okay, similarly, if I disperse solid in gas, I get aerosol also. Okay, for example, I get smoke. If you see the exhaust of automobiles, if that gets mixed in air, all that is solid particles, very small particles getting dispersed in gas, which is air. It's called aerosol. Okay, when you disperse gas in a liquid, right, you take a liquid and you mix gas, pump gas into it, and the gas gets mixed, you will get what is known as a foam. Okay, the foam, for example, is a shaving cream. Okay, similarly, if you mix a liquid and inside a liquid and make a colloidal solution, you get emulsion. For example, milk, face cream, etc. If you disperse solid inside a liquid, you get what is known as SOL, sol. Okay, for example, milk of magnesia, etc. If you mix gas in solid, right, you disperse gas inside solid. Remember, when you dispersed gas inside liquid also, it's called foam. For example, shaving cream. When you dispersed gas in solid also, it's called foam. Okay, so rubber and sponge are solids in which gas have been dispersed. Okay, if you disperse liquid in solid, it's called gel. Okay, for example, jelly, cheese, butter, all this liquid is dispersed into solid. If you disperse solid into solid, it's called solid sol. Okay, for example, colored gemstones, milky glass, etc. Again, you don't need to remember this. This is just for your information. What are type of elements? Okay, so elements are nothing but substances which have only one type of atom. Okay, single type of atom. They are metals. Metals are shiny, they are silver gray or golden yellow in color. They are ductile, they can be made into wires. They are malleable, they are made into sheets. They can be made into sheets. They make sounds when you hit them. They are good conductors of heat and electricity. Okay, these are all the properties of metals. Examples of metals are gold, silver, copper, iron, sodium, potassium. All these are metals. Okay, there are some elements. Element is nothing but an atom, right? Some atoms which are non-metals. Okay, they have variety of colors. They are poor conductors of heat and electricity. Non-metals are poor conductors of heat and electricity. For example, hydrogen, oxygen, iodine, carbon, bromine, chlorine, all these are non-metals. Okay, there are some elements which fall between metals and non-metals, in between. Okay, metals and non-metals, they are called as metalloids. They have intermediate properties between those of metals and non-metals. Example, boron, silicon and germanium. Okay. What is a compound? How is it different from a mixture? See, a compound is obtained by chemical reaction between two types of elements. So if you take one type of atom and do a chemical reaction with other kind of atom, you get a molecule, and this is called as a compound. Okay. For example, if you mix a crushed iron, okay, iron filing, that is Fe. Fe is iron atom, and sulfur, S is sulfur, that is sulfur atom. You heat it till it becomes hot, red hot. It gives a molecule known as iron sulfide, right? The molecule is nothing but a compound. See, atom is an element, but a molecule is a compound. Molecules has iron one atom and sulfur another atom, so Fes. Okay, this is a molecule which has one iron atom and one sulfur atom, and the compound thus obtained, iron sulfide, does not get attracted to magnet, whereas the iron, which is Fe, is attracted to a magnet. Okay, so compound has a different property from the element. Okay, so compound is a substance obtained by the chemical reaction between two elements, and elements are nothing but atoms. Mixture is nothing but just mixing of two things. Okay, you just mix crushed iron and sulfur, and you don't do anything to it. They will just stay as a mixture. They will not react with each other. Okay. Now, if iron sulfur mixture plus you take the iron mixture and sulfur mixture and you put dilute hydrochloric acid, it gives out hydrogen sulfide gas and iron chloride, which are two different compounds. Now, hydrogen sulfide is a gas, two atoms of hydrogen, one atom of sulfur, and it is a molecule, and it is gas. Whereas iron chloride is one atom of iron and two atoms of chlorine. So iron chloride is a solid. Okay, and if you make iron sulfide react with hydrochloric acid, which is HCl, right? Hydrochloric acid is also a compound, right? It has one atom of hydrogen and one atom of chlorine. Okay, that's why HCl. Okay, H is hydrogen, Cl is chlorine. Even the iron sulfide reacts with hydrochloric acid to give the same outputs. Okay, so can we give the classification of matter? Yes, we can give the classification of matter. Matter can be either solid, liquid or gas. Okay, now remember, your matter can be pure substance or mixture. Okay, what is a pure substance? Pure substance has only one type of particle. Either it is a pure atom or a pure molecule. Okay, pure atom means it's an element. It cannot be broken down into simpler substances. For example, pure atom can be copper, oxygen, iron, hydrogen, mercury. All these are pure atoms, different from each other by themselves. However, compounds are molecules, pure molecules, and each molecule by chemical reaction will have two or three atoms together. Okay, so each molecule of water has two hydrogen atoms and one oxygen atom, and methane has one carbon atom and four hydrogen atoms, And salt, which is NaCl, has one sodium atom and one chlorine atom. So water, methane, salt, all these are compounds and they are pure compounds. Each pure compound has one type of molecule. Okay, so element equal to atom and compound is equal to molecule. Okay, please remember, element equal to atom and compound is equal to molecule. They have fixed composition and these can be broken down using chemical reaction. For example, if you pass electricity through water, H2O, then you can sort of separate the hydrogen and oxygen. Okay, but without doing any chemical reaction, by themselves they are pure. Okay, pure substance, two types: elements, which are pure atoms, and compounds, which are pure molecules. Mixtures can be homogeneous, solutions wherein you add sugar or salt in water and mix it well, it gets dissolved. That is homogeneous. And the second type is heterogeneous. For example, if you just mix sand and salt, or you just mix sugar and salt, where the composition is not uniform, you get heterogeneous mixtures. So these are the classifications of matter.
We have thoroughly studied, digested, thought about and simplified the concepts for you. So please like, share and subscribe.